Sohcahtoa, sine, cosine, tangent. Do you know that they are ratios?
I have. Oh yeah.
Like we'd call them trigonometric ratios, and I do wonder if that is clear. Now, I wonder if we understand the term ratio. Who has an understanding what ratio means? Yeah, give it a shot.
It's like comparing two things. You do it in chemistry.
Okay, good. Where you're looking at the ratio of, is it two elements kind of thing, the mass of two elements, or
Just the compound.
the compounds? Okay. In this class, okay, so a ratio that I'm used to when my kid was in daycare, they always talked about the ratios, and that was how many kids to each adult, right? And the lower the ratio, the better. So, for example, when he was really little at daycare, it was like a 1-to-4 ratio, one adult to four kids. Okay. Then, as he got older, the ratio got worse. It would be 1-to-6, right? One adult to every six kids. Okay. So do we see that comparison? What is the adult to student ratio now for you guys? Like 1 to 30, right? We have 26 kids in this class now. So it's 1-to-26, right? And so it's a comparison. Okay. And what is helpful for ratios? We use ratios in cooking all the time, right? Like anyone cook rice, or like who cooks grains here? Rice, oatmeal. Okay, if I have 1 cup of rice, how much water do I give?
1 cup. 2 cup. It's a 1-to-1 ratio.
It is not a 1-to-1.
2-to-1 ratio.
It's a 2-to-1 ratio mostly,
I'm so
right?
silly.
Yeah, that's why your rice is crunchy. So mostly it's a 1-to-2 ratio. If you're like really good at cooking, or there are other ways, and I know some people are going to really frown on the 1-to-2 ratio, but in general, it's a 1-to-2 ratio. Well, what if I choose 3 cups of rice? How much water do I add? 6 cups of water, right? So what the ratio does, it allows us to make things bigger or smaller, right? To have more of it or less of it. And in trigonometry, sine, cosine, and tangent are ratios. Now, sine and cosine are always opposite over hypotenuse. Okay, so tell me, what is the biggest number, or what is sort of the limit to how high the ratio can be? What is the highest number that you can have? No, no. Like, actually, look at this. So, what is the sine ratio? Well, remember, O over H. It's the ratio of comparing the length of the opposite side to the length of the hypotenuse. Kajik. No. So remember, the ratio is going to be like, so we're dividing. Think of it this way. Yeah, Luke?
Does the opposite have to be less than half the hypothesis?
It does not have to be less than half the hypothesis, but you're on the hypotenuse, but you're on the right track, Luke. Yeah, it has to be less than 1. Look at it this way. If the sine ratio, which is opposite over hypotenuse, if it equals to 1, what does that tell you about the length of the opposite side? It's the same as the hypotenuse. Is that possible?
No.
No. Why? Why is that not possible? Okay, the hypotenuse is the longest side. And then think of it. Like if I were to have a length that is the exact same length as a hypotenuse, I wouldn't be able to create a right angle triangle. Okay. Now, keep in mind that sine, cosine, that these ratios are only applicable for right angle triangles. Okay, let's write that down in big letters. Only for right angle triangles. Or we don't have to say right angle. For right, Liam and guys, I'm going to have to ask Luke to move.
No, no, okay, we promise for that.
Please. Okay, I like that you're having fun. Just tone it down a bit. So, is it possible to have a triangle where two of the sides are the same length? Yeah, that's called isosceles, but we don't use Sohcahtoa on it. Sohcahtoa is only for right triangles, and the definition of a right triangle, or part of the definition, is that the adjacent side and the opposite side must be less than the hypotenuse, must be shorter. Okay? So, what that means is adjacent and opposite are less than, not less than and equal to, they are shorter than the hypotenuse. Now, me talking about the fact that a sine or cosine ratio will never reach 1 is really helpful. All right? Like, there is a situation in rotational trigonometry where sine and cosine equals to 1, but we're not talking about triangles. So that number 1 for sine and cosine is important. How about tangent? Can tangent equal to 1? So what is tangent? Tangent is the ratio opposite over adjacent. Can it equal to 1? Yeah. Can it be more than 1? Can it be like 100? Why not? All it says is that the opposite side would be 100 times longer than the adjacent side. There's no rule against the opposite and adjacent side being longer or shorter than the other. What if the tangent ratio equals to 1? What does that tell you about those two sides? Yeah, they are the same. What type of triangle are we talking about? We're talking about an isosceles right triangle. And in an isosceles right triangle, i.e., the opposite and adjacent sides are the same, we have a right angle. What are these two angles?
45.
45 degrees. They must be, right? Because what is the total? What is the sum of all angles in a triangle? 180. So if the right angle, oh my God, if the right angle is 90, then all that's left is 90 more degrees, right? So 45, 45. So if you get that the tangent equals to the tangent of an angle equals to 1, right away you're like, I know we're talking about a 45-degree angle. Okay, so these ratios allow us to find the angles. Now, what if I'm talking about about the opposite and adjacent side, and what if there are 2 centimeters and 2 centimeters of a distance, right? The angle is going to be 45. But what if my opposite and adjacent are 200 kilometers and 200 kilometers? What's the angle? Still 45. So the actual length of the sides doesn't matter when we're trying to find the angle. What matters is the ratio. It's the comparison. So you can have a ginormous triangle or a tiny triangle, still have 45 degrees, and all that matters is when you divide the two sides. So when you're comparing them. Does that kind of make sense? Okay, so as you can see, sine and cosine are more related than the tangent, right? The tangent is a bit different because what is it not using? The hypotenuse. All right, so let's do a Sohcahtoa 101. Just in case you fully forgot trigonometry, let's remember how it is that we use this. Okay, so Sohcahtoa. How do we use these formulas? So means sine equals opposite over hypotenuse. Okay. Ka, we're talking about cos equals adjacent over hypotenuse. Cosine, sine, right? These are just names for different ratios. TOA, tangent equals opposite over adjacent. Okay, so we get to use Sohcahtoa in our head if we forget the formulas or as a way to remember the formulas. Okay, so let's practice. Now, I give some steps, and we're going to have two different scenarios, one in which we need to find an angle, one in which we need to find the length of a side. Okay. Oh, Kajik, I didn't mark you present. Did you sign in at the office? Okay, thank you. Yeah, cool, cool. So, first step always is to label the triangle. And what we're labeling the triangle with is opposite, adjacent, hypotenuse. Okay. Now, in order to do this, we need to know which angle we're talking about. Okay. So let's say we have this first triangle where the angle is marked for us as 30 degrees. Okay. Put an H next to the hypotenuse. So the longest side gets an H. The adjacent one I find is always the trickiest one, so I leave that to the last one. Opposite just means it's opposite. That side, that side length is opposite from the angle. And then adjacent means next to. So adjacent is right next to the angle. Yep,
Well, if the angle was in the top right and the opposite be at the bottom.
that's right. The O and the A flip. So let's try that. In this middle triangle, where the 43 degrees is shown to us, that is the angle of interest. So go ahead and label this triangle. I know there's an A, but that's telling us find this length. So label this triangle. This is my hypotenuse, this is my opposite side, and this is my adjacent side. And then let's do one more. Okay, if this is my, if actually let's flip it. No, if this is my theta, opposite, hypotenuse, adjacent, given to you. All right, are we good here? Good. So that's always my step one, is to actually label the triangle, because then in step two, we're going to circle what you need to find. And then based on what you circle, and you're going to circle what you have and what you need. Based on what we circle, we're going to choose Sohcahtoa. So let's practice. Let's practice first finding an angle. All right, so this is the angle of interest. Go ahead and label the triangle. Okay, again, it's all about where the theta is. That's step one. Step two is circle what you have and what you need. So what do I have means what information am I given? I know the length of the hypotenuse. I know the length of the adjacent side, so I circle those two. I don't know the length of the opposite side, but I'm not asked to find it. I know I'm asked to find the angle because I'm given a variable, right? Theta is just a Greek letter, so it's a variable. So in this case, I circled A and H of the letters. So am I using so, ka, or toa? Right? Because I've got A and H, and that tells me, oh, you're using the cosine law. Sorry, not the cosine law, the cosine ratio. All right, so let's go ahead and write it out. So we've got cos theta equals adjacent over hypotenuse. I'll just write it like this now. You don't always have to write the formula. And now let's plug in what we know. So we know that the adjacent is 27 units long, hypotenuse is 50 units long. Is that going to be less than 1? Yeah, cool. All right, what are we looking to find? We're looking to find theta. So we need to isolate theta. Okay, now we already know that there is a function. We can't just like divide everything by cos. But there is an opposite operation to taking the cosine. What is it? The inverse cosine. Oh, it's the inverse function. Yes. So in order to find theta, we must take the inverse of 27 over 50, right? This is where you take your calculator. What mode is your calculator in? Do you remember? You got it. We'll touch radians this semester. I won't test you on it, but I'll explain it to you. And let's give the angle to the closest degree, so no decimals. What does it give us? Pardon? 57. And this is for you to check. Oh yeah, am I getting 57? And if you really don't have a calculator, use your phone. But folks, remember, on a test, I won't teach you how to use your calculator. All right, let's try another one. So that's if we're finding an angle, we must use the inverse function. If we're finding a side, so here we have a question. Let's do, so the angle of interest or the angle that is given is the 60 degrees. Okay, let's do step one, label the triangle with OAH. Go ahead. So the hypotenuse is always across from the right angle. This is opposite from the angle, and this is adjacent to the angle. Step two, we are circling what we have and what we need. So we have the H, we have the angle, and we are looking for the length of X. So which ratio am I using? Sohcahtoa? Yeah, once again, I'm using cosine because I've circled A and H. So when I write out the formula, I've got cosine. Now I have an angle, right? This is going to look a bit different. We're saying that the cosine of 60 is going to be X over 13. Multiply both sides by 13, and we can solve for X. All right, go ahead, punch that into your calculator, and leave your answer to the nearest tenth. How many decimals is 1/10? 2.5? 6.5. Let's see if we all agree. Did everyone write centimeters? Excellent. Are we good? Okay, last thing I want to show you before we jump into the booklet is two methods of solving. Oops, I took one out. It's two methods of solving. Um, all right. I find this one to be a bit tricky because you can't just divide both sides by 40, right? If you know what you're doing, some people will know, oh, what do you do with the X and the sine 72? You swap them. Let me show you how that's possible. Okay, but really, when you have the variable in the denominator, it will swap with the variable on the left side. Okay, take this in because there's going to be questions where the X is in the denominator and all you have to do is swap it. Okay, how is that so? So let me show you how I would solve it. The but you do not have to do this. So the first thing I'll do is I'll multiply both sides by x. This is the long way. This is sort of like the proof. Okay, so I'm multiplying both sides by x. That means that these x's cancel out, right? And now what I do? That's right. Now I divide both sides by sine 72. And that's how we get to the swap scenario. Okay? So this swap is something that you are free to do without showing the proof, right? And here I just showed you the proof of it. I'm not going to show you the T method right now. All right. It's time for a DPA. Come on up and grab your new booklet.